So with completing the square, the very first thing that you need to remember is the fact that we need perfect square trinomials. What that means is it's the square of a binomial, meaning, for example, A here. If I were to factor out the trinomial in A, how would that factor? X plus 5 times x plus 5. So we would rewrite this as x plus 5 squared. So it's the square of a binomial. It's one thing squared. That's what makes it a perfect square trinomial, because if I were to write it out, multiply it out, I'd get back to the x squared plus 10x plus 25. How about for B? Would that be an example of a perfect square trinomial? Yes. What's the only difference with it, though? We're going to have subtraction. So this would be x minus 6 times x minus 6, which we would really write as x minus 6 squared. How about for C? How would C factor? Bless you. X minus 7. So what's going to happen when we do our completing the square today is I'm actually going to kind of skip this step right here in the middle where I write it out twice. I'm just going to go straight to x minus 7 squared, or x plus 5 squared. So to get us to our perfect square trinomial, we have to figure out our new C term. And that's what we're going to do in this next part. So who remembers? How do we fill in the blank? Maria? What do we divide by 2? Yes, your B value. So you take your B value, divide it by 2, and then you square it. That's how we get what goes on the line in there. So for D here, 6 divided by 2 gives us what? And then 3 squared, 9. So 9 goes on our line. By doing that action, you're now creating the perfect square trinomial. So what would go on the line for E? 16, because negative 8 divided by 2 gives me a negative 4. Square my negative 4, and we would get a 16. Now, ones like F are a little trickier. Divide it by 2, and we end up getting what? It'd be a decimal, but we want to actually keep it as the fraction, so that when I square this, negative 3 squared is positive 9. 2 squared is 4, so we would put the fraction 9/4 on there instead of the decimal. So I have written in here for you once again the steps on how to solve by using completing the square. So first off, divide all terms by A if necessary. What that means is completing the square only works if your A is equal to a 1. So if you have any other number in front of your x squared term, you need to divide by that first, and then you can follow the steps of completing the square. You're then going to move your constant term over and set up your 2 boxes, although I put lines instead of boxes because I hate having to write in a box after I've made it. And then we divide our B term by 2 and square it, and then we go ahead and factor. So let's actually get to it. All right, so if I look at my first example down there, I have a 2x squared minus 16x minus 2. I need to divide everything first by a 2 because I can't do completing the square having that number in front of my x squared term. So that gives me x squared minus 8x minus 1 equals 0. So now that it's just an x squared, we can go ahead and do our completing the square. So I'm going to add my 1 over to the other side and put my spaces. Put a space on each side because what you add to one side of the equal sign, you've got to add over to the other side of the equal sign. So what number are we going to put on the lines? 16. 8 divided by 2 is 4. 4 squared gives us 16. And as I said, x squared minus 8x plus 16, that's our perfect square trinomial. That would factor into x minus 4 squared. You can write that middle step if you want to, but I'm going to skip it for right now. Try to make this a little bigger for you. And then that equals 17, because 1 plus 16 gives me a 17 over there. So So now these were like problems that we were doing last time. Since all of this is squared, I'm going to undo that by taking the square root of both sides. So I have x minus 4 equals plus or minus the square root of 17. Since I introduced my square root, it's plus or minus. And then there's one other thing I have to do. Add the 4 over. So I get x equals 4 plus or minus the square root of 17. You always want to put your number in front of that plus or minus. All right, so let's try our next example there. Already have an a of 1. So what I'm going to do is I'm going to take my 5 and subtract it over. So I get x squared minus 2x, and I'm going to put a space. Minus 5 and then plus a space. So now we have to figure out what are we going to put on the line. So I'm going to take my 2, divide it by 2. What do we get? 1. 1 squared is 1. So how would this factor? X minus what? X minus 1 squared. It's going to equal a negative 4. What? So we take the square root. So I get x minus 1 equals plus or minus 2i, negative under the square root sign, so it turns into an I. And then our last step, add the 1 over. Again, we want the 1 to go in front, so we get 1 plus or minus 2i. Personally, I'm a big fan of completing the square. I always try to factor first. If that doesn't work, then I go into completing the square instead of quadratic formula. I feel like it goes faster when you get used to it. All right, so then we can use completing the square to take a parabola in standard form, which would be this one over here. And we can rearrange it into vertex form. Now, I know we did talk about vertex form back in Algebra 1. I can't remember. Did you do vertex form for geometry also? No, not really. Yeah. So our vertex form, the thing that you have to keep in mind, the reason why we put it in vertex form is because then you can easily see where your vertex is. H and K make up the points of your vertex. You would change the sign of H. So if it was negative, you would change the number to positive. If it's positive, you would change the number to negative. And then K stays the way it is. So then we have over there our steps for how to do completing the square to get it into vertex form. We're going to work through it right next to it. So we're going to follow the same thing. First thing I need to do is move my 5 over so that it's with the y. And I'm going to put my extra space in there just like I would for my completing the square. So I get y minus 5 plus a space equals x squared minus 2x plus a space. What number are we going to put on the space? 1. Follow the same rules. Take 2, divided by 2, we get 1. 1 squared is 1. So I'm cleaning it up. Negative 5 plus 1 gives me a negative 4, so I now have y minus 4 over there on the left side. Factor it on the right side. What do we get? X minus 1 squared. And now because we're not solving it, we're not going to take the square root of both sides. We're trying to write it in vertex form. So what I'm going to do is I'm going to take this and move it back over to that other side. So I get x minus 1 squared plus a 4. So there's actually a few less steps when you're putting in vertex form. So then for this parabola, our vertex, here's your x value, just change your sign. So our vertex would be at the point 1. And then that's your y value, keep it the way it is. So our vertex is at the point 1, 4. All right, so let's try it again for number 2. First thing I'm going to do is move my 7 over to the other side, so I get y minus 7 plus a space equals x squared plus 8x plus a space. What number goes in our spaces? 16. 8 divided by 2 is 4. 4 squared gives us the 16. So over on my left side here, negative 7 plus 16 gives me a y plus 9. Combine my like terms there. Over on the right side, how would that factor? Yep. X plus 4 squared. So again, since we're just trying to put it in vertex form, I'm going to bring my 9 back over to the other side by subtracting it. So I'd get x plus 4 squared minus 9. That would be my vertex form. What would be the coordinates of our vertex? Very good. Negative 4, negative 9. Because it's just like with your circles. When it's in here and it's squared, you got to change the sign of it when you take it out. The 9's not in there, so it stays as it is. All right, for the quadratic function shown graph to the right has the form y equals x squared plus bx plus c. Determine its equation first in vertex form, and then determine the values of b and c. All right, so we'll do our vertex form first. So what are the coordinates of our vertex? That's what we got to first figure out. Right down here. It's the point 1 what? 1, negative 9. So when I go to write it in vertex form, it's going to become x minus 1 squared. You change the sign when you put it in there. And then minus 9. So there's our vertex form. That's the first part. They now want us to determine the values of b and c. How can we accomplish that? What do you think we have to do with this? Right here. Write it out twice, do our multiplication. We got to get it into standard form. So x minus 1 times x minus 1, and then minus a 9. So when I multiply that out, I get x squared minus 2x minus 1, and then minus our 9. So then in standard form, we get x squared minus 2x minus 10. Oh, you guys are paying attention. Good job. So that would be minus 8. Yay! I'm so happy to hear you guys caught me on that. So what are our values of b and c? B is what? Oh, not 2. Negative 2. What's c? Negative 8. You guys remember all the different parts of the parabola over there since we have our graph there? What are these things up here called? Roots. I heard the other word for it, zeros. What is this thing here? AOS. What does that stand for? Axis of symmetry. It's a vertical line, so your axis of symmetry is always written as x equals a number. So for that one, that would be x equals a 1. We're going to be working with our axis of symmetry next unit. So this one is a happy space parabola. We can have them going down also. Those are our big main key features, your zeros, your roots. Our vertex down there, which can also be called a turning point, and your axis of symmetry. You gotta make sure you remember all those. All right. Review quickly equations for a circle. So if we have a circle with these centers at the origin, our equation would be x squared plus y squared equals the radius squared. Do you remember what it is if it's not at the origin? Anybody? Starts with an x minus h squared plus y minus k squared. Still equals r squared, always equals your radius squared. So we can use completing the square to also take a circle, put it into center radius form, as we call that up there. I also gave you that formula once again right there. You got it in several different places on your notes. We will have to be graphing circles in a couple of days, so we got to remember how to do this. So if you recall, when you're given an equation for a circle and you're told to put it in center radius form, you want to collect your x's together and then put a space, your y's together, put a space, and then your numbers on the other side. So in our equation there, I have x squared plus 8x, so I'm going to start with those. X squared plus 8x. And I'm going to put my space for my completing the square process. Then we put our y's together. So plus y squared minus 6y plus a space. What do I do with that minus 75? Bring it over so it becomes a positive 75. Plus 2 spaces. One from the x's, one from the y's. So looking at our x's, if I take 8 divided by 2 and square it, what do we get? 16. So I'm going to put that in the first space on both sides of my equal sign. For my y's, take 6 divided by 2 and square it. 9. So I put 9 on both sides of my equal sign. So now we factor. So I would get x plus 4 squared for my x's. How would our y's factor? Yeah, I heard somebody say y minus 3 squared. And then what do we get for equals what? Equals 100. So what would be the center of this circle? Negative 4, 3. What would be our radius? 10. All right, then our other example, find center and radius of x squared minus 6x plus y squared equals 66. So we're going to do the same thing. X's are already together, though. So we just have to add in our space. Do we have to set up to do completing the square with my y? No, because we only have the one y squared there, so that just stays as y squared. So I'm only going to put one space next to my 66. I'm only going to be adding one number to both sides of our equal sign here. What number is that going to be? 9. Good. 6 divided by 2 squared would give us a 9. So this would be x minus 3 squared plus y squared equals what? 75. So what's our center? 3, 0. What's our radius? Ooh, but we got to simplify that. I can't leave it as a square root of 75. So what's our perfect square that goes into 75? 25. 25 times what? So the square root of 25 is, so we get 5 radical 3. Again, if you need the steps for that, we did 25 times 3. 25 is a perfect square. So the square root of 25 gave me our 5 there.